y depending upon u. Therefore, we done dy by du in case number 1. But now u equals to 2x plus 3. So u is depending upon x. So what you do? You do differentiating both sides with respect to x. So we write du by dx equals to differentiation of 2x plus 3 with respect to x. Derivative of 2x is 2 and derivative of 3, it is a 3 is a constant. Therefore, derivative of 3 equals to 0. That is 2 plus 0. That is equals to 2. Here derivative of 2x. Derivative of 2x is 2. Derivative of 3x is 3. Derivative of 4x is 4. Derivative of nx is n. You remember this one. Now, so du by dx equals to 2. Now you need to find out dy by dx. That is our ultimate aim. So dy by dx nothing but dy by du and du by dx. This is nothing but chain rule of derivative. So we are having dy by du nothing but phi u raised to 4 and du by dx is nothing but 2. That is equals to phi into 2 into u raised to 4, 10 u raised to 4. What is u? U nothing but 2x plus 3. So you write here the 2x plus 3 raised to 4. Therefore, the differentiation of 2x plus 3 raised to 5 with respect to x nothing but 10 2x plus 3 raised to 4. This is ultimate result. Thus, in chain rule, what you do? First, convert the given function into standard form. Then you do the derivative 2 times. First, dy by du, and the second time you do du by dx. Then you multiply both the results. Let us take one more example. Next example, y equals to under root of 6x plus 5. What is inside the root? Whatever it may be, not only algebra. I will take more example, under root of sin x, under root of tan x, like that. In root, any function may be there. We don't bother about that. So first of all, we write here y equals to root of 6x plus 5. Suppose only root x is there, then I will give you one formula. Whenever the root x is coming, what is the derivative of the root x? So I am going to give you one shortcut idea to how to remember the derivative of the root x. So here I am having the root x. So root x can be written as, in place of the root, you can write x raised to 1 by 2 power x raised to 1 by 2. Derivative of x raised to 1 by 2 is nothing but 1 upon 2 x raised to 1 by 2 minus 1 upon 2 x raised to 1 minus 2 upon 2 1 upon 2 x raised to minus 1 by 2 equals to 1 upon 2 root x. That means I am giving you one formula, derivative of root x with respect to x equals to 1 upon 2 root x. If you remember this formula, then your job becomes easy. So repeat once again, what is the formula for root x? Differentiation of root x equals to 1 upon 2 root x. One more time please. Differentiation of root x equals to 1 upon 2 root x. So what I do here, let u equals to 6x plus 5. Therefore y equals to root u. Now differentiating, what is the step 1? Step 1 is a dy by du and second step is a du by dx. So differentiating both sides with respect to u. So what you get here? Dy by du equals to differentiation of root u with respect to x. Now with respect to u, not x, sorry. So differentiation of root u with respect to u. Now what is the answer for root x? The answer for root x is 2 root x, 1 upon 2 root x. Derivative of root x equals to 1 upon 2 root x. Therefore derivative of root u with respect to u equals to 1 upon 2 root u. That is dy by du. Let us call it as a equation number 1. After that, but u equals to 6x plus 5. What you do? You see, whenever the given problem, step number 1, supposition u equals to, that is the step number 1. You remember it. In the chain rule, this step is valid for every problem. In the second step, dy by du equals to, we get here, call it as equation number 1. After that, you remember that, but u equals to 6x plus 5. You remember this stage. And after you are writing u here, what you do? Differentiating both sides with respect to x. What you have to write down? Differentiating both sides with respect to x. So du by dx equals to differentiation of 6x plus 5 with respect to x. Now differentiation of 6x is 6 and differentiation of 5 is 0. Therefore du by dx equals to 6. Call it as a equation 2. Now I said you in chain rule, first you get the dy by du, in the second step you get the du by dx. Now you have to multiply both of them. So what is the chain rule formula? Dy by dx equals to dy by du into du by dx. You multiply both the results. What is the result number 1? 1 upon 2 root u. And what is the second result? 6. So that is 6 upon 2 root u. Now what you do now? Here if cancellation possible, you cut down, no problem. 2 1s are 2 3s are cut down. So we get dy by dx equals to 3 upon root u. So 3 upon, what is u equals to? U equals to 6x plus 5. Therefore 3 upon 6x plus 5. Therefore the final result, how to write the final result? Therefore differentiation of root 6x plus 5 with respect to x equals to 3 upon under root of 6x plus 5. This is the result. This way we perform the chain rule. Now let us do one more example. Next example, suppose y equals to root of sin x. It is equally valid for every other trigonometric function. In place of sin x, there can be cos x, tan x, sec x, cosec x, anything. So let us do this first problem in detail. Then second problem, we will do shortcut. So first of all, y is equal to root sin x. Then step number 1, let sin x equals to u. Then we get y equals to root u. Now differentiating both side with respect to u. Therefore dy by du equals to differentiation of root u with respect to u. That is equals to 1 upon 2 root u. That is dy by du equals to 1 upon 2 root u. That is equation number 1. Actually dy by du we don't speak. We have to speak differentiation of y with respect to u. We have to speak such a big sentence. So you see I am little bit lazy. So how to speak dy by du? Okay, but step number 2, but u equals to sin x. Therefore now here u equals to sin x. Here is the RHS is sin x. U is the function of x. Therefore differentiating with respect to x both side. So we get du by dx equals to differentiation of sin x with respect to x, that is equals to cos x. So du by dx equals to cos x. Let us call it as a equation number 2. Now according to chain rule, dy by dx is nothing but multiplication of step 1 and step 2. Step 1 is dy by du and step 2 is du by dx. You need to multiply both of them. So dy by du is nothing but 1 upon 2 root u and du by dx is nothing but cos x. Now what you do now? You put back the values. Dy by dx equals to cos x upon 2 root u. What is u? U is nothing but sin x. You have to put back the value of u. If you keep u as it is, then it is not allowed. You have to at the end, what is u? U equals to sin x. You have to put back here. So dy by dx equals to cos x upon 2 root sin x. How to write that? Therefore, differentiation of root sin x with respect to x equals to cos x upon 2 root sin x. This is answer. You see, in place of sin x, there can be cos x, there can be tan x, there can be cot x, any other trigonometric functions. Then we do derivative similar way. Let us have a look. Let us take one example and understand how will you handle other trigonometric functions. Let us have another example, y equals to under root of cos x. So let cos x equals to u, then it becomes y equals to under root of u, then differentiating both sides with respect to u, then dy by du equals to differentiation of root u with respect to u equals to 1 upon 2 root u, that is dy by du. Call it as equation number 1. And after that, but you remember this, but is a turning point that comes after the step 1. U equals to cos x, then differentiating both sides with respect to x, then du by dx equals to differentiation of cos x with respect to x equals to minus sin x. Then call it as equation number 2. After that, dy by dx equals to dy by du into du by dx. What is dy by du? 1 upon 2 root u, and du by dx nothing but minus sin x. So that is equals to dy by dx equals to minus sin x upon 2 root u. So dy by dx equals to minus sin x, and what is u? U is nothing but cos x. So here the cos x will come. And how to finally write? Finally we can write differentiation of root cos x under root of cos x with respect to x equals to minus sin x upon 2 root under root of cos x minus sin x upon 2 into under root of cos x. So this is the answer. Let us have one more example. Next example, y equals to under root of tan x. Step number 1, let u equals to tan x, then y equals to under root of u dy by du equals to derivative of root u with respect to u equals to 1 upon 2 root u dy by du. Here I am doing little fast and skipping some steps as well as. I hope you are getting through. But u equals to tan x du by dx, differentiating both sides with respect to x, du by dx, that is derivative of tan x with respect to x, equals to sec square x. Now dy by dx equals to dy by dx equals to dy by du into du by dx. I corrected the equation 1 here and equation 2. dy by du nothing but 1 upon 2 root u, and du by dx is nothing but sec square x. So dy by dx equals to sec square x upon what is u? U is nothing but tan x. Therefore sec square x upon 2 into under root of tan x. This is the result. Therefore differentiation of tan x with respect to x equals to sec square x upon 2 root tan x. This is answer. Sec square x upon 2 into under root of tan x. That is, once again, differentiation of root tan x with respect to x equals to sec square x upon 2